Hello, this is Arvind Narayan from Team 54 in the Spring 2019 section of CS 6310. I'd like to demonstrate our OsMowSis project. Before demonstrating our GUI, I'll run through a quick overview of how our system is organized. I hope this will give you a basic understanding of what's under the hood, so when you see things moving around on the screen, you'll know how and why it's happening. The most important class in our implementation is the lawn square. Lawn squares contain lawn artifacts, including grass, craters, puppies, and lawnmowers. Puppies and lawnmowers can move between lawn squares, which you will see in our demo. Grass is mowed. So while each grass lawn artifact will stay on its lawn square, it may be mowed and become empty after a lawnmower passes over it. Craters just stay on their lawn squares and don't really do very much. The simulation class handles generating the GUI and orchestrating the back end of our project. Now, let's take a look at the OsMowSis application. So I'll go ahead and run main.java with an input file that I've specified in the build arguments. As you can see, the only real argument that I have is the file path to the input file that we have. Now I can also run this from the command line, but from now I'll run it from within Eclipse itself. So we see that the lawn simulation GUI has been generated. We'll see grass, we see 2 puppies, we see 3 mowers, and we see 5 craters. At the bottom of our screen, we see a simulation status box, which shows the status of the 3 mowers. We also see how much grass has been cut so far, how much grass is yet uncut, and what turn we're on. At the top, we see a simulation controls panel. So we see a next box. This basically steps through the simulation one turn at a time. We see a fast forward button, which basically fast forwards through the simulation running at a high speed so we can see the log file as soon as possible. We see a stop button, which basically stops the simulation wherever it's at, outputs a log file, so then we can go investigate it and see what happened. And then we see a reset button. The reset button basically reloads the input file and returns us to the configuration that we currently see. So first off, let's just hit the next button a couple of times and see how our simulation runs. Oops, looks like we've had a collision. You'll see that mower 1 and mower 3 have stalled, whereas mower 2 seems to be okay. The collision has happened here. So I'll go ahead and stop the simulation and investigate to see what happened. I'll open our log file, which has just been generated. Here we can see a detailed explanation of what all has happened. At the bottom, we see that these mowers have stalled, as we saw in our GUI. And also, we see that the number of squares cut and the number of turns taken resembles what we actually saw in the simulation. Now I'll run the fast forward button. So this runs the simulation through a pretty fast pace. As you can see, the mower status is dynamically updated. So that includes things like stalls due to puppies, which you've just seen. It includes things like the number of grass squares being cut. Again, I can stop this. Looks like we caught it during a collision. I'll stop it and I'll exit. And we can see the log file. Again, at the bottom, we see that there was a collision between mowers 1 and 3. And we see that on the 54th turn, we had already cut 51 out of the 75 grass squares. I'll go ahead and run the simulation one more time. This time, I'll fast forward it. I'll stop it. And then I'll reset it. Notice how reset resets the initial configuration according to the input file. We also see that the simulation status has changed to the initial simulation status. As a final demonstration, I'll go ahead and fast forward our simulation through the entire process so it can run the entire 75 turns, and you can basically see how our mowers perform. So in 75 turns, we see that we've cut about 2/3 of the lawn, and we have 24 grass that's uncut. I'll give you a little bit of a description of how our lawnmowers are working. Basically what they do is they search their surrounding area for grass. If they see grass, they move in that direction based on basically a random selection between the surrounding grass. If they see no grass around them, they'll make a random decision, which sometimes leads to collisions, but most of the time leads to places that are closer to other grass. I'll go ahead and close this. I'll check our log file. Scroll all the way to the bottom. And indeed, we see that the correct numbers are reflected here. Thank you for listening. I hope you enjoyed our application.